Hello and welcome back to my second video for the Taylor series with the remainder term. And I have a second example here. The example is to find the smallest value for n for which the nth degree Taylor series for f of x equals e to the 2x, centered at x equals 0, approximates e to the 2x on the interval 0 to 1 with an error no greater than 10 to the negative 6. So we want it to want the estimation to be within 1/1,000,000th of the actual value. So to get started on this, notice that we need to make sure we're talking about the remainder here. So this is the remainder term. And so r sub n of x is equal to f of n plus 1, the nth plus 1 derivative at c, times x to the n plus 1 over n plus 1 factorial. Right? So that would be the remainder to the nth term. So first thing we need to do is take the derivative of our function e to the 2x. So I have those derivatives taken here. Notice f prime of x would be 2e to the 2x. F double prime would be 2 times 2e to the 2x. F triple prime would be 2 times 2 times 2 e to the 2x, which is 2 cubed. So you can see the pattern. And we end up seeing that we have the nth derivative would be 2 to the n times e to the 2x. So we want to put in the remainder for the n plus 1 term. Then the n plus 1 derivative would be 2 to the n plus 1 times e to the 2c. Remember that c is the maximum, is the x value that will give you the maximum for that derivative, over n plus 1 factorial times x to the n plus 1. Again, we're taking the absolute value here because we're interested in the maximum distance and not necessarily whether the sign is positive or negative. Also remember this is for x between 0 and 1, and our c has to be between 0 and x. So let's go ahead and take a look at what that's going to mean. So we need to figure out what this is, how we maximize this value with these. So first of all, if x is 1, that's the furthest distance away from the center, so that's going to give us the greatest error. So we're going to let x equal 1. And at the same time, since e to the 2c is a function that is increasing, it's also greater on its right-hand endpoint, so we'll also let c equal 1. So when we plug that in, we end up with the maximized remainder. I made this one a little larger because we're going to be working with it. So we get 2 to the n plus 1 e squared over n plus 1 factorial. And remember, the question asked us to find the value of n that will make this remainder less than or equal to 10 to the, oh, that's supposed to be the negative 6. So let's fix that right here. So 10 to the negative 6. It helps if I have the right color, black on black. Okay, so 10 to the negative 6. All right, so what we need to do is, that's really a difficult thing to solve. We need to find out what n value does that. So we're just going to have to do it by trial and error. So what I did is I went ahead and put it in the calculator under y1. You can see here. I'll get this on the screen in the right spot. Okay, so we put it under y1, and we have e squared 2 to the x plus 1 over x plus 1 factorial. So x is standing in for our n. Now what we want to do is just look at the table of that, and we want our step. So we'll go to second table set, and we'll put the table on auto, but we're going to have the delta table equal 1. And we'll start at 1. And so then let's look at our table. So second table. It's actually easier on the TI Nspire. And then all we need to do is arrow down. I'll go to the y values because those are easier to see that. We're looking for one that's less than 10 to the negative 6. So we've got 6.3 times 10 to the negative 5, 9.7 times 10 to the negative 6, 1.4 times 10 to the negative 6, which is still a little bit bigger. So you see finally by the time we hit n equals 14, again remember x is standing in for n in this case, we find a value that gives a remainder that is less than 10 to the negative 6. So that's our answer. That ends up being our answer. I'm going to put that on the right spot here. So pull the calculator off the screen. You guys don't need to see that again. So our answer is that we need to have n equal to 14. And that will give us a remainder. So that means we need to use 14 terms. So that the remainder is less than 10 to the negative 6. So there we go. That's our answer. Oops, got a little crazy there circling. But you can see that these aren't that difficult if you just start breaking it down into those little parts. Thank you again for listening, and hopefully this helps you out.